Now according to this equation, the standard equation of underdamped, the equation is a1 e raised to power lambda 1t plus b into e raised to power lambda 2t. Okay, now we need to put it in the standard equation. I is equal to a e raised to power lambda 1t plus b e raised to power lambda 2t. So lambda 1 we got it as minus 1, right? Lambda 2 we got it as minus 1 by 2. So can I write it down? I is equal to e raised to power minus t plus b into e raised to power minus t by 2. Hmm? Okay, now we need to calculate the value of a and b, then we'll get the answer, right? So now for calculation of a, put t is equal to 0. Okay, this is the standard equation I of t. If I'll put t equal to 0 means I of 0 is equal to a into e raised to power minus 0 plus b into e raised to power minus 0 by 2 is 0 only. So it's 0, 0, e raised to power 0, 0. Anything raised to power 0 is 1. So it would be a plus b. And I of 0 means the initial condition we have already calculated. Remember, we got it as I of 0 as 2, right? So we got one of the equation that I of 0 is equal to 2 is equal to a plus b. A plus b is equal to 2. Okay. Now we got the one of the equation, but we need another equation to get the values of a and b because we are having two variables, right? So for that we'll use that KVL equation. Remember the KVL equation we have calculated for t less than t greater than 0. VR plus VL plus VC is equal to 0. Okay. So I'm writing down this equation. VR plus VL plus VC is equal to 0. VC will be as it is. This is I'm writing with respect to time. Okay. So VC of 0 and I of R, right, plus L by dt, but I'm not writing in terms of because I need to write down in terms of current. So I L into R, right? So I'm writing all this, as you can see that all these are in series connection. Here this one is series connection, so current is same, right? So I'm writing IL of T multiplied by R, IL of T multiplied by L plus VC of 0, right? Okay, IL of 0 multiplied by R plus L, DIL of dt 0 plus VC of 0. Okay, VC of 0 we have calculated earlier, that is 0, right? The initial condition we have considered here. Yeah, VC of 0 is 0, right? So VC of 0 is 0. IL of 0 we got it 2 into resistance is 3. L we already know. L is how much? 2 Henry. DIL of dt, right? So from this we'll get DIL of dt is how much? We'll get it as कितना आ रहा है? Solve it from here. Hmm. I'm re minus, correct? Okay. Now we got I of t equation, standard equation. What was the standard equation? A 2 e raised to power lambda 1 t plus b e raised to power lambda 2t. So if I differentiate it, dIL of dt is equal to a is constant e raised to power lambda t means lambda is constant, e raised to power lambda 1 t, right, plus b is constant. I'm differentiating by dt and d by dt, right? E into lambda 2 e raised to power lambda 2t, correct? dl of dt we just calculated minus 3, a we don't know, lambda 1 is minus 1, e raised to power 0 because I am putting t is equal to 0, plus b lambda 2 is minus 1 by 2 e raised to power 0. So we'll get another equation, minus 3 is equal to minus a minus b by 2. So we got two variables, two equation. One of the equation of a and b is this one, another equation of a and b is this one. Then we need to calculate a and b and need to put it into the standard equation. Okay, so this is how we do these kinds of question. It's a